All right, welcome to day 8. So today is our first of 2 review days. We're going to review the algebraic type problems in this video, and your homework will be whichever ones we don't do from pages 40 to 43. So we'll bounce around a little bit within there, and then the leftover ones are the ones that you will do for homework. So you can be putting that in your planners. There is no warm-up. We'll just be going over the homework. So we had isosceles trapezoids on the homework. Remember, along the non-parallel sides, the angles are supplementary, and then your base angles, which are along the parallel sides, are congruent. So because of that, angle 2 was 62, they had to be congruent, and then the 1 in the 62 had to be supplementary, so you had 118. Pretty similar idea for B and C, so you get 99 for angle 1, 81 for angle 2, and then 59 for angle 1 and 121 for angle 2 in C. In D, pretty much same idea. So 1 and 96 are base angles, so they're congruent, so that's 96. And then angle 1 and angle 2, because they're along a non-parallel side, should be supplementary. So 180 minus 96 gave us 84. Pretty similar idea for E and F, and you can take a moment to check your answers on those ones. All right, in 2A, you have to discern what's the important information. Well, based on our markings there, we want to set the x plus 5 and the 3x minus 3 equal to each other. When we do that, we go through and we find that x is 4, and all they wanted was the value of the variable, so we're done for that one. B, 2B is doing like we were doing in question 1, but with algebraic expressions. So something we know is that the 4x and the 6x plus 20 must be supplementary. So add those, set them equal to 180, and you get x equals 16. The reason we wanted to start there is that was an equation we could set up where we only had one variable. Well, by subbing in the 6x or 16 into 6x plus 20, that'll give us 116, and that and y should be the same. So that's where that y is 116 is coming from. Over in C, you just have your markings of the congruent sides in the isosceles triangle. Set those equal, you end up getting x equals 1. All right, and then we had a proof on number 3. So we're given that bottom part's an isosceles trapezoid. We're given we have a set of parallel lines. We want to prove that CDE, that top triangle, is isosceles. So we want to think either a set of congruent sides or a set of congruent base angles. Well, the isosceles trapezoid we know has congruent base angles. So in step 3, we get angle A congruent to angle B. And then we can do parallel lines implies congruent corresponding angles. So that's going to give us this angle congruent to that angle. Oops, and this angle congruent to that angle. Well, notice A and B had double markings. That leads to transitive property. So first, angle A is congruent to what I called angle 1 and angle B. So we can say 1 congruent to B by the transitive property. So we now have angle 1 congruent to angle B. Well, now 1 and B are congruent, and I covered up the 2 there. 2 and B are congruent, so we can say 1 and 2 are congruent by transitive property. And then you can do 2 congruent base angles implies isosceles triangle. All right, so we're going to start out on page 40, and we're going to look at review the properties of each of our quadrilaterals. Now, kind of our flowchart hierarchy that we have for a bunch of them, you've got parallelogram, you've got rectangle and rhombus, and then you've got square. As soon as something has a property, all the ones below it have a property. So like the square has all the parallelogram properties, rectangle has all the parallelogram properties, and so forth. So the ones below it in the flowchart have the properties of the ones above. So diagonals bisect each other. We want to think about on our study card, what's the first figure that we have that implies diagonals bisect each other? And the first one that has that is the parallelogram. Well, because the parallelogram has that, all the ones beneath it on the flowchart have it, so does rectangle, rhombus, and square. Next, we want to think, what's the first one that implies diagonals congruent? Well, that's the rectangle. And then everything below it on the flowchart must also have it, so the square has it as well. Which is the first one that has opposite angles congruent? Well, that's one of our 5 parallelogram properties. So parallelogram has that. Everything below it on the flowchart has it as well, so the other 3 do. Diagonals perpendicular. The first thing that implies diagonals perpendicular was the rhombus. So the rhombus has that, and everything below that, so in other words, the square, will also have that property. Opposite sides parallel. The first place that we have opposite sides parallel is with our parallelogram. So the parallelogram has opposite sides parallel, and then everything below that on the flow chart. So in other words, the other 3 things have opposite sides parallel. First one that has 4 right angles is the rectangle, and then everything underneath that in the flow chart, so the square, also has that property. First one that implies opposite sides congruent from our study card is the parallelogram. So everything below that on the flow chart has it as well. So rectangle, rhombus, and square. Now in reality, rhombus does have opposite sides congruent, but it actually has all sides congruent as well. Same thing with the square. Next up, consecutive angles are supplementary. The first time we see that a figure implies consecutive angles supplementary is with the parallelogram. So everything beneath that on the flow chart has it as well. So that means rectangle, rhombus, and square all have that. 4 congruent sides. The first time we see that is rhombus. So then everything below it on the flow chart has it as well. So just square. And the first time we have something implied that the diagonals bisect the angles is again the rhombus. So everything below that has it as well. So the square. So knowing the things on your card and knowing this flow chart picture is helpful. When it shows up on our card, all the figures below it on the flow chart have that property as well. So we're going to try and do the harder questions in this video. So we're going to start with question 7 now and work to the end, and then we'll end up leaving 2 through 6 for you to do for homework. So let's flip ahead to question 7. All right, we've got an isosceles trapezoid. Whenever you aren't given a picture, it's a good idea to sketch that picture. So let's draw ourselves an isosceles trapezoid. 2 opposite angles, we have 2x plus 20 and 3x. So maybe I'll label the 2x plus 20 here, and I'll label the 3x there. Since it's isosceles, we know those are the same. Well, in an isosceles trapezoid, the base angles, the ones along the parallel sides, they're congruent. So we know that this is also 3x. And along the non-parallel sides, those angles are supplementary. So this angle and this angle should add to 180. So we can do 3x plus 2x plus 20 equals 180. Combining like terms, we get 5x plus 20 equals 180. Subtract the 20 over. 5x is equal to 160. Divide by 5 and we get x is 32. reread the question, see if that's what we want or if we need to sub in. And in this case, all they wanted was the value of x, so we are done. All right, moving to 8. The diagonals of a rhombus measure 8 and 10. We don't have a picture, so let's go ahead and draw that. So here's our rhombus. I'm going to draw in my diagonals. And it's a little tricky to label. This is the shorter one, so let's call that 8. This is the longer one, let's call that 10. Well, whenever you're working with diagonals of the rhombus and you want to do anything with the sides, we're going to use the fact that a rhombus implies diagonals are perpendicular. Well, perpendicular lines imply right angles, meaning each of those triangles in there are right triangles. We also know from the parallelogram properties that a rhombus has diagonals that will bisect each other. So if that whole diagonal is 8, each of these parts will be 4. And if that whole diagonal is 10, each of these parts will be 5. And what we could do is we can set up a little right triangle with legs of 5 and 4 and do a Pythagorean theorem now to find one of the sides in the rhombus. So let's call that C for right now. We'll have 5 squared plus 4 squared equals C squared. That's 25 plus 16 equals C squared. Or 41 equals C squared. And when we take the square root, we'll have square root of 41 equals C. And let's just leave it as that for right now. Well, we want to find the perimeter. A rhombus implies that all 4 sides are congruent. So all of these would be square root of 41. So for our perimeter, essentially we have 4 times square root of 41. Or you could do square root of 41 plus square root of 41 plus square root of 41 plus square root of 41. Now, they want our perimeter not in the exact form, but to the nearest tenth. So we can put this in the calculator and we'll get 25.612 and change. Rounding to the nearest tenth, we'll look at the spot after. We've got a 1. So that will keep the 6 as is. So we'll have 25.6. We do have units in this problem, and a perimeter is a one-dimensional measurement. So we would have 25.6 meters. We'll move on to question 9 next. In 9, it was nice they gave us a picture. They already told us it's a rhombus. We want to automatically think, okay, we know this implies all sides congruent. So let's go ahead and put our markings in for that. We know rhombus implies diagonals are perpendicular, so we know that's got a right angle. And we know rhombus implies diagonals bisect the angles. So we know things like 1 and 2 are congruent. We know things like 3 and 4 are congruent. Now, I only mentioned the new things you get for a rhombus. We get all the things that a parallelogram has as well, so keep that in mind. So angle 2, they told us right here, was 7x minus 6. Angle 3, they told us here, was 11x minus 12. And because we have that they're perpendicular, we have this as a right angle as well. Well, notice in that triangle, the bottom triangle there, we have the 3 angles marked up. We know the angles in a triangle have to add to 180. So we have 7x minus 6 plus 11x minus 12 plus 90 should equal 180. Well, from there we can combine like terms. 7x and 11x is 18x. Negative 6 and negative 12 is negative 18. When you add it to the 90, that's 72. Subtract the 72 over. So you get 18x is equal to 108. And when you divide by 18, we get x is just 6. Reread the question. That's all we wanted. So we just need to circle that. In 10, we've got a parallelogram. We're not given a picture, so let's go ahead and draw that. It's parallelogram dogs. When we label that, we need to label around in a circle. So I'm going to start with D here, O, G, and S. But in reality, wherever you start with D, just go around in a circle labeling the other ones. The diagonals, they said, are meeting at M. So we've got DG, the whole thing here, is 4x plus 6. And DM is 3x minus 1. So if we think about a parallelogram and the 5 things it implies, we want to think about, well, what do we know about diagonals? A parallelogram implies diagonals bisect each other. Well, segment bisector then implies midpoint. Midpoint implies 2 congruent segments. So we know this must be equal to this. Well, if the one of them is labeled 3x minus 1, we can also label that one 3x minus 1. Well, the 2 parts together should equal DG. So we have 3x minus 1 plus 3x minus 1 should equal 4x plus 6. Combining like terms, we get 6x minus 2 equals 4x plus 6. We can subtract the 4x over. 2x minus 2 is equal to 6. Add the 2 over. 2x is equal to 8. And divide by 2, we get x is 4. Double check the problem and see what we wanted. We just wanted to find the value of x, so we are done. Always be sure to recheck the problem because sometimes you will have to sub back in. Next one's a rectangle. They tell us something for angle 1, we've got 3x plus 14. Something for angle 4, we got 2x minus 9. Well, rectangle, we have, in addition to the parallelogram things, we have diagonals are congruent. Probably not going to help us here because we're working with angles. And we also have rectangle implies 4 right angles. So keep in mind this big angle here is a right angle. So let's think of this triangle here. We've got the 3 angles. The angles in a triangle should add to 180. So we've got 3x plus 14 plus 2x minus 9 plus the 90 is equal to 180. So very similar to what we saw with that rhombus question a couple ago, just using the fact the angles in a triangle add to 180. So this will give us 5x plus 95 equals 180. If we subtract the 95 over, we get 5x is 85. And divide both sides by 5, we'll get x is 17. Well, reread the question. We didn't want to just find x, we want to find angle 1. Well, angle 1 is right here. So angle 1 is going to equal 3 times 17 plus 14. Three times 17 will give us 51. And when you add those together, we get 65 degrees. All right, one last one. We'll look at this video, and then the rest on these pages will be your homework. So the last one, we've got a square. They didn't give us a picture, so let's draw it. We'll label it MATH. Make sure to go around in a circle as you're labeling it. they tell us values for m to t and a to h. So mt, they told us, is 8x minus 6, and a to h is 7x minus 2. Well, we don't have anything on our cards for square implies, and that's because the square has all the properties of the parallelogram, the rectangle, and the rhombus. We're working with diagonals here, and we're specifically working with lengths of diagonals. So we want to think about what things do we know about diagonals from those other ones. Well, in a parallelogram, we have parallelogram implies diagonals bisect each other. So that would allow us to work with the parts of each diagonal. In a rectangle, we have rectangle implies diagonals congruent. So that's the one we're going to want to use in this case. We know AH and MT must be congruent because square has all the properties of the rectangle. If they're congruent, we'll just set them equal to each other. I'll maybe start by subtracting the 7x over. So you got negative 2 equals x minus 6. We'll add the 6 over, so 4 equals x. And reread the question. We don't just want x, we want to find mt. Well, mt was the 8x minus 6, so we'll have 8 times 4 minus 6. That gives us 32 minus 6. Or in other words, mt is just 26. So your homework, which you can start working on with any time left in the period, is you have questions 2 through 6 from these same pages. So you can be working on those now, and any you don't finish are your homework, which would be due next class. Have a great rest of your day.